Hi, friends. Happy Monday. Sorry, I am not there today, but I'll be back tomorrow. And we're going to have this awesome video for you to learn from. And then it's a bonus because you can look back at it later if you missed anything or if you want to review. So, today we are going to talk about the things that we covered on Friday and take some notes, make sure we got it all straightened out. And then we're going to talk a little bit more about what I mentioned on Friday about how scientists communicate with each other. So we're focusing on ionic bonds, and we're going to talk about ionic bonds and then ionic compounds, and it's going to be awesome. So you just should have picked up your KUD for this new unit. Make sure your name is on it. And we're going to go ahead and highlight all of the vocab words that we're going to cover today. And then at the end, you can go back and make sure that you have a definition or some information written down for each word. So we are going to go through quite a bit today, but hopefully it's not too long. So chemical bond, molecule, formula unit, octet rule, ionic bond, electrostatic attraction, crystalline structure. Crystalline? I actually don't know how to say that right. Whatever, we'll figure it out by later. Okay, and then electrolyte, and that's where we're going to stop. So we got a little bit to go, but a lot of it is refreshing from Friday. So first, we're going to define the octet rule. We've talked about this a couple times, but we're going to put it in words right now. So the octet rule is that atoms have the most stability when they have 8 valence electrons. So atoms have the most stability when they have 8 valence electrons. We know this. We've talked about this all the past unit or two. An easy way to remember octet rule is oct means 8, just like in octopus. Has 8 tentacles or whatever. And then a key concept to understand when we're talking about the octet rule is that all bonding occurs to stabilize valence electrons. So if a bond is created, the reason it's happening is to stabilize those valence electrons and to try to get to a full octet. So there's 3 ways that atoms will complete their octet. We're going to skip number 1 for today, and then we're going to write down number 2 is, well, actually, let's just put it in number 1. Who cares? We can do whatever we want. The first way that we're going to talk about is to transfer valence electrons to or from another atom. And yes, you're right. This is an ionic bond. But first, before we talk about specifically ionic bonds, we're going to get a couple definitions. So draw an arrow down from this how to complete the octet rule. So these 3 ways all relate to one type of bond. But more generally, they all make a chemical bond. A chemical bond is a lasting attraction between atoms that enables the formation of chemical compounds. So all chemical compounds are made by chemical bonds, which are all made to complete the octet rule. And just one more vocab we're going to write down here is a molecule, which we have been talking about molecules since almost the first unit, but we're going to, again, just get a definition down to refresh. So a molecule is 2 or more atoms bonded together aka the smallest unit of a chemical compound. All right. Now, let's get into some specifics. We're going to review from Friday's lab. Friday's lab, we talked about ionic compounds, which are made by ionic bonds. So we're going to fill in this table with properties of ionic substances. So what happens to the electrons? They could either be transferred, shared, or delocalized. In ionic bonds, they are transferred because they go from the cation to the anion, or they go from the metal to the nonmetal, which is a spoiler type of elements involved, metals and nonmetals. Now, do they have a high electronegativity difference or a low difference? It's high because metals are all the way on the left and nonmetals are all the way on the right. And so if you follow that electronegativity trend, nonmetals have a much higher electronegativity. They attract those electrons. Now, melting and boiling point. We found in the lab that ionic compounds have a very high melting point, and that would also mean it has a high boiling point. And we could also dissolve the salt in water, but we say mostly soluble because there are some ionic compounds that aren't completely soluble in water. And then electrical conductivity. We found that they were not conductive as solids, but once we dissolved them, they are conductive in solution. All right, so those are our properties of ionic compounds. Now, let's turn over to the next page. And we are going to get a lot of notes on more properties of ionic compounds. So, first up, we're going to explain the structure of an ionic bond using these two terms. These are two of our vocab that we're going to cover today. So, ionic compounds consist of cations and anions. Let's write that down. Ionic compounds. So when you're talking about structure, you got to include what's there and then how it's arranged. So we're going to get that it consists of cations and anions that bond to each other. And then this is how they're arranged. They bond to each other via electrostatic attraction. Now, this is one of our vocab words. And once they bond to each other, they form one formula unit. Okay, now let's get some definitions for these crazy words. First up, a formula unit. This is the simplest ratio of ions in an ionic compound. And we will come back to this in a minute when we talk about writing formulas, but just so you have the definition right here. And we will get the electrostatic attraction definition in this next question. So multiple of these, still talking about the structure, multiple of these formula units. Most of the time, a formula unit is just like one or two atoms bonded together. So multiple of these create a repeating pattern known as the crystalline structure. Getting one of our vocab words knocked out. Crystalline structure is a highly ordered arrangement of atoms or molecules. And you can write that definition, or I like to draw a little example. So you've seen this from your lab. There was a picture on there. So it kind of looks like a cube. It's like we got all these formula units or molecules that are kind of in this crystal structure, all kind of interacting with each other in a repeating pattern. It's very strong attraction, and it makes it very stable. Okay. And then lastly, because of the high electronegativity difference, it makes you get a higher strength of your ionic bond. So just remember, when you have a big electronegativity difference, the ionic bond is going to be stronger because it strengthens that crystalline structure and the repeating pattern. Makes it really stable and makes a really strong bond. Okay, so moving on. We figured out the structure, and now we're going to talk about why ionic compounds have a higher melting and boiling point. They're very stable if that has a higher melting or boiling point. Okay, so just in general, to melt or boil a substance, you need enough energy to overcome the intermolecular forces. Okay, so to melt or boil a substance, you need enough energy to overcome the intermolecular forces, or we often say IMFs. Draw a little arrow out to the side, and we're going to give some context. What is an IMF? This is the force between molecules. If you break down the word inter, kind of means between, molecule, and then forces. Force between molecules. Boom. And just finish out this sentence, to overcome the intermolecular forces that keep particles close together. Or we can just say that hold particles close together. Cool. So the electrostatic attraction, which we'll get the definition of in just a second, of ionic molecules is strong. So you need a higher temperature to melt or boil them. A higher temp to melt or boil them. Higher temperature means higher average kinetic energy. So again, you need an energy to overcome those forces. So you're trying to pull the atoms apart, so you have a lot of energy involved, so you need a higher temperature. Let's get a definition. We need to leave some space because when we talk about covalent compounds, we're going to come in and say why covalent compounds do not have as high of a boiling point. So just draw one more bullet point and then leave that there for when we come back later. Oh, I erased that on accident. Okay, so now drawing an arrow from electrostatic attraction. This is the force that pulls the positive and negative ions together. Or, as we say all the time in this class and in life, opposites attract. Okay, so electrostatic attraction is the force that pulls the positive and negative ions together. And that's what keeps ionic compounds being a compound and not being separate ions. Speaking of separate ions, let's talk about ionic compounds in water. So, first, let's get a definition of electrolytes. I gotta turn my page back somewhere else. Actually, I don't have it written down. So we're just going to write what we have for the explanation, and then we'll get the definition later. But it's basically in there. So, okay. In aqueous solution, which is something dissolved in water. The ions in ionic compounds can dissociate, which dissociate just means separate, if you want to write that down. Separate, which can dissociate from each other, become their own thing, and now they can conduct electricity because there's a positive and negative side, just like in that battery. In solution, yeah. Again, we're in a water mixed with this compound that just broke up, so now it's a solution. So that makes them electrolytes. So basically, electrolytes just means it conducts electricity in solution. And then again, leave a bullet point for when we come back to talk about covalent compounds. Just to kind of give you a picture, let's draw a little, let's say this is our compound. And then you put it in water. And it breaks up into some ions. This over here was neutral. And now it's charged. So the electricity can move all around, conduct. Okay, now we are going to turn over and do a little bit of practice because we just got a lot of information, and let's kind of make sure we can keep it all sorted out in our head. So using this word bank, we're on page number 6. First up, using this word bank, fill in the table with the correct properties of these different types of substances. Today, we're just talking about ionic, so that's all we're going to do. So you're going to use this word bank and write everything that you think applies to ionic compounds, and then we will come back together. So it'll pause and give you a question, and then when you're done, I will show you the full answer. Okay, so we're back. Let's go over the answers.